Hi, I am Gentu Kilagorja from Group 5. In our group, we're about to discuss solve problems involving permutation and combination. Our objective for today's learning is to solve problems involving permutation and combination.
Number 1. Use to determine the number of ways to arrange R objects chosen from n distinct objects in which order matters. The formula was npr equals n factorial over n minus r factorial. Number 2. Use to determine the number of distinguishable permutations of n objects, R of which are alike. The formula is P equals n factorial over R1 factorial, R2 factorial, R3 factorial, and so on. Number 3. Use to determine the number of circular permutations of n things in which anti-clockwise and clockwise order of arrangements are indistinguishable. The formula is P equals to n minus 1 factorial over 2. Number 4. The permutations without repetition. It is a case wherein we must reduce the number of available choices each time. The formula E n equals n factorial. Number 5. The circular permutation looks the same when it's turned over, such as necklace that have clasps. The second arrangement appears. The formula P equals n factorial over 2. Number 6. Used to determine the number of circular permutations of n things in which clockwise and anti-clockwise arrangements can be distinguished. The formula is P equals to n minus 1 factorial. Number 7. Used to determine the number of possible arrangement of things to choose from, and we choose R of them regardless the order. The formula C n R equals n factorial over n minus r factorial r factorial.
Yung formula.
Lastly, number 8. The permutations with repetition. It happens when a thing has n different types. We have n choices each time. The formula is P equals to n r exponent.
In the previous self-learning modules, we have learned about the definition of permutation and combination and when to use it. In this lesson, your understanding of the topic will be deepened. You will apply your prior knowledge in solving problems involving permutation and combinations. However, for you to be able to successfully answer combinatorics problem, first identify whether the problem involves permutation or combination. Remember that the difference between combinations and permutation is order. In permutations, we care about the order of the elements. It will often contain words like arrange, in a row, or in order. Whereas with combinations, we don't. Instead, these problems have to do with groups of things in ways that the order doesn't matter. The following examples and exercises are presented to facilitate learning.
Example 1. In a meeting, it is required to seat 4 women and 5 men in a row so that the women will occupy the even places. How many arrangements are possible? Solution. The keyword in a row pertains to the arrangement of the elements that requires order, and so the problem involves permutation. The total number of places is 9, thus the arrangement in a row can be illustrated using blank spaces. Since it's stated in the problem that women occupy the even places, the arrangement in a row of 4 women and 5 men is in an alternating form. The 4 women can be arranged occupying even places in P, n, and n equals P, 4 and 4 equals 4 factorial equals 24 ways. 5 men can be arranged on the remaining 5 places in P, n, and n equals P, 5 and 5 equals 5 factorial equals 120 ways. Therefore, the number of arrangements by FCP are 24 times 120 equals 2,880 ways.
Example number 2. How many different possible permutations can be made from the word circle such that the vowels will never be together? Solution. The problem already stated that it is a permutation. However, the arrangement of the elements in the word circle, the vowels will never be together. This type of arrangement is a distinguishable permutation with some conditions or restrictions. The equation will be the different possible permutations can be made from the word circle such that the vowels will never be together equals the number of possible permutations can be made from the word circle subtracted by the number of possible permutations with vowels I and E always together. The word circle has six letters in which I letter occurs twice and the rest are all different. The number of possible permutations that can be made from the word circle is P equals n factorial over C factorial, I factorial, R factorial, L factorial, E factorial equals to 6 factorial over 2 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial equals 360 ways. The vowels that should come together will consider as a single letter and need to permute again since it contains another arrangement. Hence, the number of possible permutations with vowels I and E always together is 120 ways. Using the equation, the different possible permutations can be made from the word circle, such that the vowels will never be together is P equals 360 minus 120 is equals to 240 ways.
Example number 3. How many straight lines can be formed by 8 points of which 3 are collinear? Solution. Suppose there are n points in a plane and out of which n points, m points are collinear. In short, each of this selection can generate a straight line, but the m points are in the straight line. Hence, we can make only one straight line using these points. Therefore, we must subtract MC2 minus 1 from NC2. So the number of straight lines that can be formed by joining these endpoints is NC2 minus MC2 plus 1. Here n equals 8 and m equals 3. From 8 points, the number of ways to choose to form a line is 8C2 ways equals 28 lines. Suppose the three collinear points are A, B, and C. The following are the combinations: AB and BA, AC and CA, BC and CB. And these three pairs of lines constitute one straight line. The number of ways to choose two to form a line in these points is 3C2 ways equals 3 lines. Hence, the number of straight lines can be formed by 8 points of which 3 are collinear is 8C2 minus 3C2 plus 1 equals 26 lines.
Example number 4. A committee of 5 persons is to be formed from 6 men and 4 women. In how many ways can this be done when at least 2 women were included? Solution. This type of problem involves combination. At least 2 women included means the committee can be formed either with 2 or 3 or 4 women. The following are the possible selections of committee of 5 that includes at least 2 women. 2 women and 3 men can be done in 4C2 times 6C3 ways. 3 women and 2 men can be done in 4C3 times 6C2 ways. 4 women and 1 man can be done in 4C4 times 6C1 ways. The total number of ways of forming the committee is 4C2 times 6C3 plus 4C3 times 6C2 plus 4C4 times 6C1 is equals to 186 ways.
Example number 5. If 3 mathematics books have been selected from 5 different mathematics books and 4 English books have been chosen from 6 different English books, in how many ways can 7 books be arranged on a shelf if 3 mathematics books remain together? Solution. This type of problem involves permutation and combination. Number of ways of selecting 3 mathematics books from 5 different mathematics books is 5C3 ways. Similarly, the number of ways of selecting 4 English books from 6 different English books is 6C4 ways. Number of ways of arranging 3 mathematics books remain together and 4 English books is 5P5 equals 5 ways. Num- Number of ways of arranging 3 mathematics books among themselves is 3p3 equals 3 ways. To illustrate, let M as the math book and E as the English book. Hence, the required number of ways is 5C3 times 6C4, 5 times 3 equals 180,000 ways.
Additional example. How many different 5-digit numbers can be formed from the digits 1, 2, 3, 4, and 5? A. If the number is greater than 50,000 and no repetitions are allowed. B. The number is even and repetitions are allowed. 5A. Yung ma-form ng mga numbers ay greater than 50,000. 5 na yung unahan ng mga numbers. Ang pagpipiliin ay 5, 4, 3, 2, and 1. Obvious na ilalagay lagi yung 5 sa unahan. 4 na numbers na lang ang kailangan para makabuo ng 5-digit number. So, pipili sa 4, 3, 2, and 1. Ang napili ay number 3. May natira pa na tatlo. Pili ulit sa 4, 2, and 1. May dalawa na matitira. Kaya naging 1 factorial yung 5 kasi, di ba magiging constant na siya sa unang place, kaya more than 50,000 yung kailangan. Multiply, 1 factorial na siya. 24 ang final answer. 5B. Number 2 ang even number sa 5, 4, 3, 2, 1. So, kailangan na maging even yung last digit para maging even yung 5 digit na yun. Kailangan mag-end sa even number. Magiging 2 factorial siya. Repetition is allowed. 2 times 5 to the fourth power is equals to 2 times 625. 1,250 numbers ang final answer.
And that's it for today's lesson. I hope you've learned something from today. And we are the Group 5.